simplistic design, right? So you don't have to specify a lot of different things. And it's more like Lego blocks. So you add layer by layer to make anything that you would like to create, right? So it's like a neural network Legos block. That's what we're looking at. And we will specify that using sequential layer, and then we'll specify some of the other parameters. Um, activation functions are defined, weights are initialized, right? So I'm just going to move forward to it provides many loss functions, right? So some of these loss functions are there: MSE, MAPE, hinge, log loss, so on and so forth. Cross entropy is what we use. Different types of optimizers to adjust the weight very quickly, like SGD. We talk about ADAM, ADAGRAD, ADAMAX, ADA all of these optimizers, right? So backward propagation, and it has the L1 and L2 regularization as well. Again, something that we'll discuss maybe in a future lecture, but nothing as of now. Dropout functionality is there. You can do a validation of this, and where you can actually know what is happening. So let's see who would like to interpret this model. What do you think this model might be doing? Hmm. Sequential meaning it's basically the Lego blocks. It's going to be added on top of each other. Yeah. So we just say model sequential. We are initializing that,
and then we are adding one more dense layer where the first dense layer having the number of neurons is 16.
Yeah.
But in that input layer, we are having 10 features of 10 neurons. So can say it like that.
It is going to expect input of 10 features,
10
right?
features,
And it is going to have 16 neurons.
Yeah.
Yeah.
And we are using that activation layer as ReLU.
Yeah.
And then we are adding one more layer with 8 neurons. Okay. And then again one more with activation ReLU, same like 4 neurons with activation ReLU. And then the output layer will be having a dense layer, one output, I think, either 0 or 1. Okay.
And the activation is sigmoid, so it will tell you 0 or 1.
0 or 1, probability, whatever.
Yeah. Next slide.
We are compiling and we are giving that optimizer as add-on. And binary cross entropy, that is the loss. That is the loss
function. The loss function, correct? Yeah.
And then we are doing normal fit and predict.
Right. So and then you are fitting the model on the train and predicting on the test.
Yeah.
And this is the layer that you see in the bottom actually. Like this is how your model is. You see that input is 10, then 16, ReLU activation, dense 8, ReLU activation, dense 4, ReLU activation, dense, and then sigmoid activation in the end. That's what we're looking at. I hope this is clear. The architecture of the neural network. Huh? More or less? We have 3 hidden layers. Yeah. Input, and then these are your hidden layers that you're looking at. Dense 16, dense 8, dense 4. Yeah. The output, input and output layer. First one is the input layer, and then output layer.
In the first layer, we have to say that how many inputs are there.
Inputs are expected, yeah. Okay, let's look at one more. I think they have other ones as well. So what do you think this is doing? Any guesses? You can take time to look into it. This network. This is a different network actually, slightly different. Or maybe it's the same thing, but we're adding more things actually. Same. Right.
Yeah, it's doing the same fit function, but it is doing the early stopping based on some criteria.
Right. So you can stop basically keyboard intervention. So if the neural network is taking a long time, you can say, if I press the keyboard intervention, then you can actually stop the neural early stopping, right? And it is also specifying the validation. So it will look into your training and validation simultaneously and see what is the error that you're getting, right? Yeah. Right. And we'll do some of this so that you can understand live, right? But I mean, these are very simpler neural networks that you can look at. But let's just now go to I think I have that link over here. If not, then I'll dig it up. Hmm? Same way, it's going to do the train test. I don't think I have that link over here. So let me send you. So if you go to Quora, this is what the network is that we will be building on our own. Well, maybe not. Oh, no wonder, because I'm not in the right place. I have signed in using my Pandey build. Diabetes. Quora. Didn't come up. Okay. I'll just go. This is the one that I was looking for. So I'm just sending you this code, and this is a direct copy paste. So that saves you a lot of efforts. Huh? This is a diabetes data set. So I think you may have it, or you may need to find where it is, right? I will see if I can find it for you as well. Huh? You have worked on this data set or no? Pima Indians. You have not worked on. Let me see if I can find it. Pima you have not worked on. Pima. Okay, I think Kaggle, I'll have to just take a look. You have it. Diabetes Pima. Can you share with all of us? Pima Indian. So this is the one I'm looking at. So you can also take a look at this link for people who would like to download on their own. Small file. I'm already logged in, so I'm just going to download this file just to confirm whether this is the correct one. It has pregnancies, glucose, blood pressure, skin thickness, insurance, BMI, diabetes, pedigree, function, age, outcome. I think this is what we are looking at, right? That's fine. I'll just send you the link in case if you would like to download on your own while Vasu is trying to send. I think I have already shared that link, so you can just pull in from there.
It will be the same file.
Same file. Or is yours different?
Some of the columns will be
Oh, is it? Okay.
outcome, yeah, it's test and then outcome. The label is like
Uh-huh. Mm-hmm. It's different, huh? then you can pull from Kaggle, or you can work with the one that you have. It doesn't matter. It should have 6912 if I'm looking at the right data. Just confirm whether that is the case with you or not. Hmm? 6912. But that's okay. I mean, as long as it looks familiar from that link that I've shared with you, you can move forward. Not every code is required, so just be cognizant of that. So I'm just gonna Hmm? The link that I've shared with you on the chat window. Code is direct copy pastable. But just be aware of what you're typing. Not everything is required. Yeah, a lot of things are not required for you. You're doing in Jupyter Notebook?
Yes.
You have to install Keras. Then look at my previous link. Otherwise, you have to do it in the collab. If you're doing in the Jupyter Notebook, the link that I've shared with you over here. First, you need to install TensorFlow and then Keras. Acha, this is the same article link. Wow, I found it now. Here is the link, I think. $47. Well, not this. 47, or was it in 48? No, it doesn't look like that. Set up deep learning environment in Python. That is the one. Set up deep learning environment in Python. That is the one that you'd follow. Otherwise, you can switch to Collab. And I'm gonna move forward. So if I miss out something, then I will definitely try to import those packages. So this is very cool thing when I was doing this. So you can actually display this video, right? So within the Jupyter Collab environment, you can play that video. This talks about what this data is, right? So you may want to take a look at this video to understand. So that's that video. Then what I'm going to do is I will read the data. What? I didn't define that. It is defined. Import pandas SPT. So this is how my data looks like. So let me know if you have something similar or different. Oh, it doesn't have that many rows. It has only 768 rows. 768. Yeah, 768. Yeah, sorry. 698 is the data size. 768 times 9. That's the number I was telling you. The number of elements basically. So it's 768. Small data. Right. You're getting 392? Where? Size will tell you that because 6912 you're getting, na? 392. Just do the like this one, Tejashri, the shape. You should get 768 times 9. Let's see. Hmm? Where did you get the data from? Can you try from the Kaggle also? Can you try from Kaggle also the link that I've shared with you? Or I will send you. Let me just send it actually. I think just to avoid the confusion. Just give me a moment. Yeah. I'm just sending you the file. Work with this one, just to be on safe side. You should have the file now, Tejasvi. We'll just work with that. That should be fine. Import standard scalar. Hmm? Is it fine? Yeah, that's the one we are looking at. The one I've sent you. That will be better. Is it? Then I don't know why there was some difference. Just why? Predict underscore classes. They've deprecated predict underscore classes, so we'll have to figure out what they are actually using now. Oh, is it? You've already sent it, chat. Got it. Argmax. Point 0.64. Try adding more neurons and more layers. Try adding more neurons, more layers, and do a validation as well. So just do some quick Googling on adding a validation layer in your model. And let's do a confusion matrix as well. Huh? Matrix dot classification report. Okay, too many parentheses. So there is some error here. It doesn't work out that way. Some error. That's what's giving you some warning here. Precision and F-score are ill-defined and being set to zero in label with no predicted samples. Use zero division parameter to control this behavior. Something it's not able to comprehend. That's why classes type of classes. Let's check out very quickly. NumPy array. Okay, that's fine. All are zeros. All are zeros. That's the thing. All are zero. Okay. So 123 divided by 192. Let's see. 123 divided by 192 is your 64% accuracy. So it's not doing any prediction at all for you. That's where your accuracy is coming in. So it's basically doing all of them are zero. All of them do not have the disease. That's why you're getting the 64% accuracy. Remember the conversation we were having this morning? Same thing. That's saying nobody has disease. So I'm getting 64% accuracy. But that means your precision and your recall is zero for class one. Exactly the same hypothetical problem that we're talking about this morning is repeated over here. So now you can do the diagnostic why that is the case. Is something wrong with the argmax or something wrong with the prediction? Just let's see. So model dot evaluate scores, right? So scores, we got good scores over here. So model dot predict. Let's see what the predict looks like very quickly. Something is happening over here. Oh, underscore X, yeah. So this argmax is wrong actually. Can somebody figure out what should be the right way to do that probability? So there is a probability that is figured out, but we're not able to convert. That argmax is not going to work. Probabilities are there. We can do the probability based. I mean, we can do our own thing, but I'm just trying to figure out. I don't know why they have done that actually. This is not the right thing from Keris's point of view. So there might be something that we're not aware of. Otherwise, I can give you the threshold cut that you can use.
Argmax is at particular.
Uh-huh.
There is some other one.
Right. Yeah, you can use this one right here. Yeah. Let's use this one. Because this is what the threshold one was, if you remember. We use the same way that, I mean, if the probability is this, then I'm going to call that as this. Yeah. Hmm? Yeah, that's just in terms of, validating things, right? So let's just try. So model dot predict. I think the parenthesis is not in the right location. Yeah, this is there. And this predict will be starting over here. Everything is in the predict function. No, That won't work. So model.predict. Actually, let's just do it in the 2 steps. I think that'll be simpler. So we have the predict X coming in, which is the probability, right? So from here, what we're going to do is we will define that like we are looking at over here, right? So this is your probability. So we will just say this predict X is more than 0.5. That's all we have to say. So classes, if predict X is more than, oops, control Z, we'll say predict X is nothing but a probability. And then we say if this probability is more than 0.5, that is the more than sign here, 0.5, and then we will do this as type int. Right? This should work. There you go. Right? So now do predict X, which comes in. And let's do classes also. After this line, let's do classes. It should have now mix. It has a mix. Now let's do accuracy. Should improve. Let's do classification. There you go. Right? So this is the change we have to make, folks. This is your, I'll just mark it so that you know what we are doing. So this is basically doing the probability. This is doing the classes. Huh? No, somehow they've deprecated that. Only probability they are telling you. Which one? This code. Right? Okay, so this sort of like gives you a demo of how to build your neural network, right? So this is a very, very simple baby example of neural network. That you can try out. You can try Keras adding a validation layer. You can add a validation, but you need to have a validation data set defined as well. We haven't defined that. Keras validation data. Or maybe you can do the split there as well. Let's see. Over here, so when you're doing the model.fit, you can add a validation split. If you want to do a quick validation while you're fitting the model as well. So let me just try that. So model.fit, you're passing on your X and Y, all these things. I mean, you can see how detailed this input is, right? I mean, I'm not going to try all of them, but let's just see one of that. So now you can see within this X train, Y train data, it has split your validation data also, and it is telling you the accuracy on that validation data as we're training, right? And it's not looking that great actually. Sorry, validation accuracy is coming in over here. So yeah, still not looking that great. So what we can do is we can increase the number of epochs to let it train for longer period of time. So let's try 50 now. Let's see what happens. You will see what really happens then. going to take some bit of time, but not necessarily that long a time. It has already sort of like, done, yeah, complete. So validation accuracy went as high as 68%. You can see now we are overfitting the data. You can see that, right? I mean, validation accuracy went as high as 71%. Now, because we are doing too many epochs, it has come down to 64. So maybe I'm just telling you, like, a quick way of analyzing what is happening in your network. Somewhere around 25, let's try 25 epochs. 75. Okay, that's good. So let's try 30 epochs then. This is a quick way of sort of like, what is happening in your network, whether you're getting in the overfitting territory or not. How are you knowing the overfitting? Can anyone tell me? When this accuracy is going higher and higher and the validation accuracy is coming down, that means you're overfitting. So that's why I'm actually eyeballing it, that I mean, it should not necessarily deviate too much from that trend. Right, so 70%, and it should continuously rise. So I think there is still opportunity for me to train more. Still rising more, 68, 70 I have topped, right? Anyway, let's evaluate what comes out now. 76% accuracy on the test. Okay, so in this case, probably it's more robust model, but it has dropped because it's not overfitting. That's I mean, nothing to be sort of like worried about, because it's saying that you have a more generalizable model. All right, so that was it for the agenda that I have for today. Any questions, thoughts from anyone before we wrap up? Any general Q&A? Folks online, do you have any questions for me before we wrap up? This file? Yeah, you can share. It's the same thing that we have there. No problem. I'll just download and share.
And could you share Excel sheet also, sir? Hello?
Okay, I'm sending this file, so you should get it momentarily. Sai Kiran, were you saying something? I didn't have my earphone on. I missed it.
Yeah, sir, that Excel sheet also, sir. That you
Excel
wrote
sheet,
all
yeah,
the
yeah,
stuff.
yeah.
Yes, yes.
But I don't know whether you will be able to recognize my handwriting though. That's okay. I'll just send it to you.
And next week we have exam right now, sir.
Next week you have exam. So that's why you need the Excel file. Huh? Next week we have the exam, but mostly gonna be conceptual and the doer part of that notes. Today's day 4. EML. 20th.
And could you share the sample question paper or something, sir?
There is no sample question paper. Just work with whatever we have discussed. It will be more demonstration than like sharing the theoretical knowledge.
Okay, sir.
So I can give you data set, for example, that you're supposed to build a model, write your commentary, analyze whatever it is coming out, and maybe some conceptual questions.
Okay, sir.
Any other questions, thoughts, folks, from anyone? No? All good?
So, we'll also question.
Not necessary. So I can give you, for example, like time series, for example. Time series, you spend a lot of time talking about that, right? So time series, definitely you can bet there will be something, right? I can give you a classification problem and leave it up to you to figure out what technique you're going to use to fit it. You can use MLP, which is a neural network. You can use something else and so on and so forth. Make sense? I don't think people who have paid attention, they should be worried. I mean, it should be very, very straightforward. Nothing challenging at all. Pranish, you have any challenges? Network is gone. Okay, okay. Yeah, you can remove the dropout because it's just like a very, very small data. Yeah, you're just trying to get how to optimize the performance. Saikiran, anything else from your side, Bhumika? Anything from your side? You're good, Saikiran?
Yeah, sir.
Okay. So then this is it, folks. Thank you so much and look forward to connecting again. Hmm? BFSI, yeah. I'll come back in BFSI. I'm closing the meeting then, Saikiran.
Yeah, sir. Thank you, sir. Happy weekend, sir.
Thank you. Take care.